This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Welcome to the discussion. Today we're delving into a research paper titled Toward Understanding Retrieval Accuracy and Prompt Quality in RAG Systems. This paper explores the intricacies of retrieval augmented generation RAG systems, focusing on how design choices impact their performance. Let's start with the fundamentals. What are RAG systems and why are they important?
RAG systems enhance large language models, LLMs, by augmenting them with external knowledge bases. Instead of relying solely on the LLM's internal knowledge, RAG systems retrieve relevant information from an indexed database, incorporating it into the LLM's prompt. This addresses several limitations of standalone LLMs, such as hallucination, fabricating information, and limited context windows. The importance lies in improving accuracy, reliability, and the ability to handle complex, knowledge-intensive tasks.
The paper highlights several design factors influencing RAG system performance. Can you elaborate on the 4 key factors they identified?
The paper focuses on 1. Retrieval document type, the nature of the retrieved documents, oracle, distracting, irrelevant. 2. Retrieval recall, the percentage of relevant documents successfully retrieved. 3. Document selection, the number of retrieved documents included in the prompt. 4. Prompt techniques, the methods used to construct the prompt, including zero-shot, few-shot, chain of thought, etc. Each factor significantly impacts the system's correctness and confidence.
The findings regarding retrieval document type are particularly interesting. The paper mentions distracting and irrelevant documents. Can you explain their impact and the surprising magic word effect?
Distracting documents, while seemingly relevant, actually hinder performance. Irrelevant documents, surprisingly, sometimes improve code generation, an effect they termed the magic word effect. This isn't simply due to increased prompt length, it seems to be a more nuanced interaction between the irrelevant information and the LLM's processing. The magic word effect is most pronounced when using irrelevant documents alone, particularly those from a different domain, diff documents.
That's counterintuitive. How does the paper explain this magic word effect? What are the potential mechanisms at play?
The paper doesn't offer a definitive explanation, but it suggests that the irrelevant information might somehow prime the LLM, improving its ability to generate code. Further research is needed to fully understand this phenomenon. It's a fascinating area for future investigation, potentially revealing new ways to optimize LLMs.
Let's move on to retrieval recall. The paper found a wide range in the recall needed for IJAZ systems to outperform standalone LLMs. What were those ranges, and what does this imply for practical applications?
The required retrieval recall varied significantly, from as low as 20% to 100%, depending on the model, dataset, and task. This highlights the importance of carefully considering the specific context when designing a RAG system. A one-size-fits-all approach is unlikely to be optimal. Furthermore, even with perfect recall, 100%, RAG systems still underperformed in some cases where standalone LLMs succeeded.
The paper also investigated document selection and prompt techniques. What were the key findings in these areas?
Adding more documents to the prompt can increase the chance of including useful information, but it also increases the risk of introducing noise and misleading the LLM. The optimal number of documents is task-dependent. Regarding prompt techniques, the paper found that their effectiveness is highly context-specific. Most techniques didn't consistently outperform a simple zero-shot prompt.
The paper concludes with several guidelines for developers. Can you summarize some of the most impactful ones?
Several key guidelines emerged. Avoid distracting documents. Monitor using perplexity in QA tasks. Consider using irrelevant documents, especially diff documents, to potentially improve code generation. Perplexity can be a useful metric for evaluating retrieval quality in QA, but not in code generation. Even perfect retrieval doesn't guarantee success. LLMs can still misunderstand the information. Carefully consider the number of documents included in the prompt. Adding too many can hurt performance. In multitask RAG systems, prioritize generalizable prompts over highly specialized ones. Advanced prompt techniques can solve problems the baseline can't, but they might fail on simpler tasks.
This discussion has highlighted the complexities and nuances of designing effective RAG systems. The paper's findings challenge some common assumptions and offer valuable insights for practitioners. Thank you.